Have you ever heard that in a room full of 23 people, there's a 50% chance that 2 of them will share the same birthday? But aren't there so many possible birthdays and so few people? When calculating a probability, it's often easier to work out the opposite scenario. So let's start off with the probability that you and I have 2 different birthdays. So I can have any of the 365 birthdays I want, and you have to have any of the other 364, giving us a probability of 99.7. If there's a third person, they'll have to choose among the 363 leftover birthdays, and a fourth person will have to choose among any of the 362. Do this with 23 people, and the probability that we all have unique birthdays is around 50%, meaning the opposite scenario, that there's some overlap somewhere, is the other 50%. The reason why is because even though there's a very low probability of any 2 people sharing the same birthday, there are so many pairs of people we can match up and compare in that room, much more than just 23. Here's the story of how the Greek mathematician Eratosthenes became the first ever to calculate the circumference of the Earth over 2,000 years ago. Eratosthenes heard that in a city south of Alexandria called Kyne, the sun cast no vertical shadows on the noon of the solstice, so the sun was directly overhead. He correctly assumed that the sun was far enough away that its rays were practically parallel once they hit the earth, except instead of casting no vertical shadows in Alexandria, a stick that he planted in the ground actually cast a shadow of about 7.2 degrees, which could only mean one thing, that there's some curvature in the land separating Alexandria and Kyne. And because of the rules of parallel lines, the angle of 7.2 degrees created by the shadow is the same angle separating Alexandria and Kyne. He knew that the distance between the 2 cities was about 800 kilometers, so 7.2 degrees is to 360 what 800 is to the full circumference of the Earth. So Eratosthenes solved this equation to come up with a circumference which was very close to what we've now verified through satellites, all using nothing but a stick and his brain. So I recently had the misfortune of coming across this video.
This is America.
First of all, these numbers are actually just based on a survey of 243,000 people. That's about 0.07% of the American population, 1% of which reported being victims of violent crime. These figures appear to be extremely specific, as if we counted every single one, but they're actually just extrapolations from a sample. Even if these numbers were close to the true figures, even if I give you that, if white people really had it that much worse than black people, wouldn't that just make America more horrible? The protests going on right now are not a matter of black on white crime or white on black. This is about a corrupt justice system that is letting police get away with murder. Well, if you don't like it here, why don't you just leave? Right, because when the government said you couldn't own slaves anymore, did people just move away? Pretty sure they started a civil war. If you really love America as much as you say you do, why not get on board to make it a better place? Okay, let's talk about these crime statistics that I've been seeing thrown around that are apparently from the FBI. Now, first of all, why is this being taken per 1 million of the murderer's race and not the victims? This is giving the false illusion that if you were a white person killed in 2013, you were about equally as likely to have been killed by a black murderer as you were a white murderer. But this is disputed by the very source that was cited. What really bugs me about people using crime statistics like this is they're trying to sneakily suggest that black people are just more violent. Either you believe that black people are just genetically predisposed to violence, and if that's the case, I honestly just don't even know how to reason with you anymore, or you recognize that there must be external factors contributing to the inequity, like, I don't know, the war on drugs, redlining, gun violence, poverty. Are you bringing that same energy to those discussions, or does your passion for crime statistics end at poning liberals? You hear a lot about the first man on the moon and very little about all the work and ingenuity it took to get him there. The mathematician Katherine Johnson was one of the first ever black women to be a NASA scientist. She faced racial and gender segregation. She had to use separate bathrooms because she was black. She wasn't allowed to put her name on papers because she was a woman. And despite that, it eventually became clear to everyone that her work was among the best. When electronic computers were just being invented, the officials called on Johnson to verify the computer's numbers by hand. John Glenn, the first American in orbit, refused to fly without her assurance specifically. Katherine Johnson only died this year in 2020, meaning your life overlapped with hers. And she achieved lots more than most of us will achieve. And yet, imagine what she might have achieved if she did not have those barriers. Barriers which, in one way or another, still exist today.
Black men commit over half the violent crime, but only make up 14% of the population.
Explain to me why 13% of the population is responsible for 50% of the murder.
When you make up 13% of the population, but you're responsible for more than 50% of the homicides, African Americans are more violent.
Let me tell you about a thing called circular reasoning. That's when you assume the thing you're trying to prove. For example, the government isn't racist, black people just commit more crimes. And you can trust the numbers because the government is fair. The government isn't racist. Do you see the problem with that logic? This comes down to how we get the crime numbers in the first place, which is subject to sampling bias. Not everybody who breaks the law gets convicted of a crime, and not everybody who gets convicted of a crime broke the law. Which race do you think makes up the highest number of exonerations? Since Becky is so convinced that black people are just more violent, I'm really interested to hear what she has to say about black people making up disproportionately more exonerations than convictions. Are they just genetically prone to being exonerated? I invite any conservative to explain this to me. Okay, so I was horrified to see this graph posted by CNBC because it appears as though, based on the headline in the graph, that the economy is all back to normal, in fact, maybe even better. But this graph is misleading because it only plots job losses and gains, which is a rate of change. This is your real-life application of calculus you were looking for. This 2.5 million only means there are 2.5 million more jobs in May than there were in April. If we were to plot the actual employment levels of people, that graph would look like this, which gives a very different picture. Sure, things are not as bad as they were last month, at least in terms of jobs.
Hopefully George is looking down right now and saying this is a great thing that's happening for our country.
Black unemployment went up by 0.1%. Asian American unemployment went up by 0.5%. How is that a victory?
You are something.
How is that a victory?
Thank you very much.
Riddle of the day. Can you spot the problem in this picture? Okay, politics aside, this is only a math question, so pause here and think about it. Okay, how do gears work? On a very elementary level, say these are the teeth of the gear. If a gear is turning clockwise, any gear that it's attached to is going to turn counterclockwise, or just in the opposite direction. So in this diagram, let's say between the Canada and Mexico gear, one of them's clockwise, the other's counterclockwise, then which way is the USA gear turning? It can't be opposite to both of them. The system would just be jammed. Numberphile has a good video showing how 3 gears can work in 3 dimensions, but on a flat plane, any odd number of gears that are all connected in a loop will not work. And yet artists still like to draw it that way. Probably they don't know. It's become a meme at this point for conservatives to say things like, facts don't care about your feelings, facts can't be racist, to fortify their arguments when they're invoking statistics. The thing is, there is no such thing as a statistical fact. There are facts about statistical theory, but no statistic in itself is objective truth. It was George Box that once said, all the models are wrong, but some are useful. It's just not possible for us to represent a real-world phenomenon with statistical modeling because there are too many factors in real life. Statistics can be biased, they can be racist. That's why the most important part of every study is to check the assumptions, name the biases, name the sources of error, scrutinize the methodology. But anyway, you would think that somebody so concerned with facts would surely agree with the top health experts about their opinions on COVID-19, right?
What are your thoughts on that, Ben?
I mean, the unbelievable stupidity. These people are scientists like Dr. Nick is a doctor on The Simpsons. I mean, this is madness at a high level.
I've got a feeling he doesn't care about the facts. Okay, so some of you guys have asked me to explain this scene from Mean Girls.
Find the limit of this equation.
The limit does not exist.
First, to give you a very quick lesson, a limit is essentially what the function approaches as x approaches a particular value. So as x approaches 2, this function approaches 4. As x approaches infinity, this function approaches 0. And as x approaches 0, this function approaches infinity. Now, some textbooks might say that this limit does not exist, but in my education, personally, it's always been perfectly fine to write that the limit equals infinity. Anyway, the reason the limit from the Mean Girls scene does not exist is actually quite obvious when you graph the function. So as x approaches 0, it's actually ambiguous. Does the function approach infinity or negative infinity? It depends on whether you look at it from the left or the right. Therefore, the limit does not exist. Whenever people make Mean Girls references like, oh my god, the limit to the number of chicken nuggets I could eat right now does not exist, doesn't exactly mean what they think it means. The word limit has a different definition to a mathematician than it does in the colloquial sense. Riddle of the day. So Achilles is racing against a tortoise and he gives the tortoise a head start. When it's his time to go, it'll take him some time to catch up to the tortoise, but by the time he reaches that point, the tortoise will have moved forward a little bit. And in the time that it takes Achilles to catch up to that point, the tortoise will have another chance to move forward even more and maintain its lead. By that logic, the tortoise will always maintain a lead and Achilles will never catch up to it. But how is that possible? So this paradox takes us back to ancient Greece with Zeno of Elea, who believed that this proved that all motion was simply an illusion. But of course Achilles can run. He can outrun the tortoise and in a finite period of time. The fact that you can divide a finite period of time and a finite distance into infinite segments is no contradiction. Take half of a pie and then add a quarter and then add an eighth and then a 16th. Each time you're adding half of the remaining empty space. Then you'll have yourself an infinite sum of numbers all greater than 0, but still all adding up to 1. Riddle of the day. Say that there's a 10% chance of rain on any given day, independent of all other days. If it rains today, what day is the most likely to be the next time that it rains? Pause here and give it some thought. So the answer is surprisingly tomorrow. The chance that tomorrow is the next time you see rain is simply the same as the chance of it raining at all tomorrow, which is 10%. If we wanted for the day after tomorrow to be the next time it rains, that means it can't rain at all tomorrow. So we have to multiply the probability of no rain tomorrow times rain the next day for 9%. For the day after that to be the next rainfall, that means we have to have no rain for 2 consecutive days. So we have to multiply these 3 probabilities to get 8.1%, and it just keeps shrinking day after day. The key is that I did not ask what day is it most likely to rain. I asked what day is it most likely to be the next rain. Just imagine you had to wait an entire year for the next rainfall. You'd be very unlucky. So that's why it makes sense for the probabilities to keep shrinking as time goes on. If you ever tell someone to pick a random number between 1 and 10, they tend to pick 7 over any other number. 1 and 10 are too close to the edges, even numbers don't feel random enough, and 3 and 9 are also too close to the edges, and 5 is right in the middle, so you're left with 7. A professor once asked his students to flip a coin 200 times in a row and write down the results, and he could usually tell with pretty good accuracy who actually did the assignment, because the students who were actually flipping a coin would eventually reach some chains of seeing multiple heads in a row or multiple tails in a row, whereas a student who thought they could get away with just making up H's and T's didn't put enough chains like this. Probably because they felt that this type of chain didn't feel random enough, even though it technically has the same probability of happening as this one. It goes to show humans are lousy random number machines. Our idea of randomness is too skewed by what we think it should look like, and people have formalized this logic to be able to scope out embezzlement, lazy accounting, and even election fraud. I want to tell you guys about a study done by the American Economic Institute called Are Emily and Greg More Employable Than Lakeisha and Jamal? They created 5,000 resumes and randomized the names on them, giving half of them distinctively white-sounding names and the other half black-sounding names, and sent them out to job ads in Chicago and Boston. What they found was that the resumes with distinctively white-sounding names were getting, on average, 50% more callbacks than those with black-sounding names. The average white applicant would have needed to send out about 10 resumes to get a single callback, where a black applicant would have needed 15. Furthermore, having a white-sounding name on a resume yielded as many more callbacks as 8 additional years of experience. And the names were completely randomized, which implies that employers were indeed using race as a factor in reviewing resumes. Just remember that racism is not just someone in a hood, it's also a matter of our subconscious biases that we might not even be aware of, but that are creating unfair hurdles for Black people. Okay, why does 0 factorial equal 1? Well, for starters, a factorial of a positive whole number is all the whole numbers less than or equal to it all multiplied together. So 4 factorial is 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1, so you see the pattern. 3 factorial is the same as 4 factorial divided by 4. 2 factorial is the same as 3 factorial divided by 3, and 1 factorial is the same as 2 factorial if I divided it by 2. Therefore, 0 factorial should be the same as 1 factorial divided by 1, which equals 1. Another way to think about it is a factorial is how many different ways you can rearrange n things. So if I have 3 different things, I can rearrange those in 6 different ways. I have 3 options for the first position, 2 options for the second position, and 1 leftover option for the last position. 3 times 2 times 1. Well, how many different ways can I rearrange 0 things? Only 1. What is the difference between a theory and a theorem? Well, in everyday language, a theory is just a hunch, but in science, a theory is a reliable explanation of the real world. It's substantiated by evidence, reasoning, scrutiny, for example, the theory of gravity or the theory of evolution. These theories embody our entire library of knowledge about how planets move or about how life came to be so diverse. A theorem is a mathematical word, and it's a proposition that we know to be true based on a chain of logical reasoning. For example, the Pythagorean theorem. That's no library of knowledge, that's just one single statement that I can summarize in a sentence. As new evidence comes in, a scientific theory can be updated or tweaked, but once a mathematical theorem is proven to be true, it will always be true and never changed. The Pythagorean theorem was true for the thousands of years we've known about it, and it will always be true for thousands of years to come. When I say to think of a number, what kind of number do you think of? Most people think of what's called the natural numbers. These are all the counting numbers, the positive whole numbers. If you want to include 0 and the negative whole numbers, these are called the integers. Rational numbers are fractions made up of any 2 integers. And by the way, a whole number is a fraction because you can divide it by 1. Notice that whenever you want to write a fraction as a decimal, you always either get a number that terminates or repeats. Pi, on the other hand, is a decimal which never terminates and never repeats. So we call this type of number irrational. Irrational numbers can never be written as a fraction of 2 integers, even though some estimates come close. So if I were to draw a little world's map, this is where all our numbers would live, and this whole set is called the real numbers. Okay, so this is a good question. I recently did a video talking about the whole world of the real numbers, and somebody asked, how do the imaginary numbers fit in? Well, imagine all the real numbers as being on a number line. So you have all the natural numbers, all the integers, pi would be between 3 and 4, and every real number can be plotted somewhere on this line. Well, the imaginary numbers would actually form a new axis. So if I go like that, I have I, negative I, 2i. This guy here would be 3 plus 2i. And a complex number has a real component and an imaginary component. So if these are the real numbers, these are the imaginary numbers, this entire world is called the complex numbers.
This math problem nearly broke the internet.
Okay, so my short answer to this is that it's technically 16 because of BEDMAS, order of operations, all that jazz. But these kinds of questions are honestly a pet peeve to me because I have never written division or even seen it written that way since like grade 5. Once you learn about fractions, every problem involving division becomes a fraction. So to me, seeing the 2 and 4 written next to each other like this seems like they want it to be written this way, which would indicate the answer is 1. But if that's not what we're meant to do, the 4 should go up here or even just outside of the fraction, which would indicate the answer is 16. The fact that this is ambiguous is a problem because sometimes you're presenting numbers to your boss, to the government, a computer, and these numbers represent real world things, coordinates for a plane to land or stocks to sell, and there has to be no room for ambiguity. So that's achieved with better notation, like using brackets and using fractions for division. Even when communicating out loud, you can say 8 divided by 2 all multiplied by 4 if you want the answer to be 16, or you can say 8 divided by the product of 2 times 4 if the answer is 1. 8% of 25 is the same as 25% of 8. Why is that? Well, percent just means per 100. So 8% just means 8 in 100 or 0.08. But 8 divided by 100 is just the same as 8 times 1 in 100. Well, I can reorder this and get the same answer. 2 times 3 is the same as 3 times 2. So these two lines are the exact same thing. But 25 times 1 in 100 is the same as 25 divided by 100, which is 25%. You can do the same thing with any two numbers. So let's say P and Q. P% of Q is the same as P times 1 in 100 times Q, which is the same thing as P times Q%. Blaise Pascal was a French mathematician who also happened to be a devout Catholic. He offered a mathematical reason on why you should believe in God called Pascal's wager. First of all, he starts with the assumption that none of us can truly know whether or not God exists. It just comes down to a choice of belief. If God doesn't exist, then you lose nothing and gain nothing by believing or disbelieving. However, in the event that God does exist, then you stand to gain infinite rewards by believing and going to heaven, or avoid infinite losses by disbelieving and going to hell. So it seems the rational choice is to believe. So what do you guys think about this? Because for the record, I'm an atheist. Okay, some of you guys had questions about BEDMAS ever since I mentioned it in a video. Some of you guys learned it as PEMDAS. Algebraically, there is no difference between a parenthesis and a bracket. This is technically a parenthesis, this is a bracket, but there is no difference between this equation and this equation. Lots of people say brackets when they really mean parentheses, but in terms of order of operations, they're the exact same thing. It can be good communication to use a mixture of them to help people see what is inside what, because sometimes you have so many brackets going on. So here you would just start from the inside working out, evaluating this, and then this, everything inside the square brackets, and then multiply by 2 and add 1. Now, why does BEDMAS and PEMDAS seem to mix up multiplication and division? Well, they don't, because technically they're the same exact operation. So when you see them on the same level, just evaluate from left to right. Dividing by 2 is the same as multiplying by a half. Multiplying by 4 is the same as dividing by a quarter, of course, with the exception of 0. Here's a fun fact about parentheses versus brackets, because I recently said that they mean the exact same thing when it comes to order of operations, but in other branches of math, they mean very different things. For example, interval notation, this means every number between 0 and 1, not including 0 and 1 themselves. So this would be called an open interval. A closed interval, on the other hand, uses square brackets. So this means every number between 0 and 1, including 0 and 1. This includes 0, but doesn't include 1. Let's talk percentages and sales. Let's say that an item is 15% off and it's originally $100. How much do you pay for it? 15% of 100 is 15, but that's what you save, not what you pay. What you pay is 85% of the price, or $85. Instead of putting the sale percentage in your calculator, you should always put 1 minus that, because what you pay matters more than what you save. And here's another reason. Let's say an item is 15% off and you're allowed to stack on a 20% off coupon. Is that the same thing as being 35% off? If it was 35% off, you would have to pay 65% of the price. However, by stacking a 15% discount and a 20% discount, that's the same as paying 0.85 times 0.80, which is the same as 0.68. Notice these are two different numbers. That would be equivalent to a 32% discount, not 35. This is how you stack multiple discounts together. Never add them. Riddle of the day. So to give you a bit of background, here in Ontario, we pay a 13% sales tax, so the total comes out to 13% higher than what's on the price tag. With a discount, you're going to be paying 1 minus that discount percentage, and with a tax, it's going to be 1 plus that percentage. So in my case, it would be 1.13. I shop at a store where the discount they give me is that they shed the tax. So the question for you is that the same thing as giving me a 13% off coupon and then paying 13% tax on top of that? Pause here and think about it. In order for a 13% discount and a 13% tax to cancel each other out, so in other words, pay what's on the price tag, these two numbers would have to multiply to 1, but they don't. So the answer is no. The equivalent discount, which would actually cancel out the tax, would be the x that satisfies this equation here, which actually turns out to be a little less than 13%. This is actually not necessarily true. First of all, pi is not infinite, it just has infinitely many non-zero digits after the decimal that never repeat, as is the case for every irrational number, and as it happens, most numbers are irrational. It's been said that the rational numbers are like stars in the sky and the irrationals are like the blackness. But just because a number is irrational and has infinitely many digits after the decimal and seem to go on randomly forever, that doesn't mean that it has to contain every finite sequence of numbers. Lots of people make this mistake about pi. They say pi contains your name, your phone number, your birthday, your social security, the Bible, and everything we have checked has indeed been found in pi, but that doesn't mean that everything that can be checked will be found in pi. The kind of number you're referring to, the kind of number that contains every possible finite sequence of numbers somewhere inside of it, does have a name and it's called a normal number, but we have yet to prove whether pi is one of them. A normal number contains every finite sequence of digits imaginable. Your name, your phone number, your birthday, a billion-digit long string of ones, anything and everything you can imagine. Many people mistakenly claim that pi is one of these numbers, which, as I said in my last video, has yet to be proven. As a matter of fact, the normal numbers that we know of are incredibly few and far between. I'll tell you one example, and it's called Champernowne's constant. It goes 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and so on. It contains every sequence of digits because that's how it's constructed. This number does contain your phone number, the Encyclopedia Britannica, the works of William Shakespeare, and everything and anything you can imagine. Every book that's ever been written and can be written, every picture that's ever been taken and can be taken, converted to numbers, of course. If that's not amazing enough to you, the proofs show us that almost every real number has this property. So while it seems magical and wondrous, you could say the property is just normal.